manually one part of what you intend to script, then you haven't yet decided what to draw. Okay? Very, very often questions that you ask me, I'll probably end up referring you back to this or asking you, how would you manually draw this if you intended to do it? As you go through that, you'll find that, oh, I don't have that data, or I don't have a particular piece of it. Well, you haven't actually gone through and tried yet. So if you cannot manually draw one part of what you intend to script, then you haven't yet decided what to draw. Your ideas must be related by actual numbers and geometry in order to give measure to your drawings. I don't mind helping people solve problems that you run into. But just be mindful that you must at least try to draw it by hand in order to think through how you would script it. Even the example on Tuesday from the workshop, we're going through it, how we would define it how we would draw it by hand. We're saying, if we drew it by hand, we would start at this point, we would find the next contour to draw to, and then we would draw a perpendicular line to it. Okay, so that's drawing by hand. Okay. So the first part, and for next week's tutorial, we will review parts that relate more to this part, and this week relate more to the second part. The reason for that is the order is that the second part relates quite a bit more to helping you understand lists, that we talked about last week, rather than this one that just gets us back to manipulating and representing data. So part one, scripting-assisted analysis. Create at least one diagram or a series of diagrams using script-assisted techniques to communicate an essential part of your project. Now this is actually, there are probably two difficult things to this, besides actually writing the script. One is deciding what is relevant in your project to represent. Of course, that's the obvious one. The second one is deciding what actually is best to represent given what you know about parametrics. That's kind of what this all boils down to. Given the skills that you're learning, what can you potentially use them for? That's always a question you ask yourself when you're working on a project. You ask yourself, given all of the things that I know and all the things I can potentially learn, what can I potentially do with them? Okay? Those are just as important as, conceptually, what can I represent? Because, or what should I represent, rather, based on the project that I'm working on. So it's a struggle between those two. It's a struggle between what you should represent and what you can be able to represent. And the amount of how innovative those methods are in the representation can often determine what you end up putting in your projects as representation. So if you can do something and do it well, then that might also help determine what you're focusing on. Your process should involve automation and methods of indexing data and geometry that we'll talk about a lot more next week. Next week we will take lists of data that are external to our software and put them in and try and make representations such as scaled circles, linking, taking a list of point data and then putting that into GIS and working with it. So some very, very basic things in terms of that, which are all part of this script-assisted analysis portion. So your process should involve combine both raster and vector modes of representation. Just work with vectors, work with rasters, and work with them in the same aligned space. You are encouraged to seek external input data if necessary. Some potential methods include, and you can already start to see how scripting assists all of these types of things. For instance, you could have a series of buildings or footprints, a series of lakes, a series of townships, etc., that could be filtered based on their area, their z-value, their perimeter length, etc. So you could query particular geometric attributes and then categorize and do something with those. Creating arrays of measured data, querying a grid for means, maximums, etc., sampling spot heights. It's very, very easy to say, given a point in space, or given 500 points in space, what is the elevation of that particular point? Okay. All of that can very, very easily be done through scripting. If you can do it for one, you can do it for all of them. The deliverables are in digital format at 200 dpi in A1 landscape TIFF of that series, or it could just be one large diagram. Okay, but you should aim at a final representation of A3. Okay, just a normal A3, not too big, but. Whenever, and I think you should try to bring this into your workflows, whenever you're aiming for A3, it's best to draw at A1. Whenever you're aiming for A4, it's best to draw at A2. Okay? So that you actually get a fairly large amount of detail, things that can be shown on the wall, etc. Okay? So not looking for a bunch of individual different diagrams that are chained and linked together. We are looking for script-assisted techniques. It could be an iterative series, similar to the project that was shown on the left with the various water flows. Okay. That could be a series. Could also be one single diagram that takes up the majority of the page. But all of those should be considered one drawing, and the methods that produce it should be succinct and systematic. Okay? So not a lot of individual attention to particular parts, but systematic attention to the entire drawing. The second part to that is a typology or topology storyboard. For this exercise, you will work at the smaller scale that you chose in your GIS work, or if you want to, you could work at an even smaller scale than that. But the point is to get down to real physical geometry of some kind. Following the examples that we'll go over today, you are asked to create a typological and/or topological transformation of landscape patterns. Parametric logical design allows a single typology or topology to be explored quickly and efficiently. These should form an array or field of forms that are responsive to impending climatic, political, and/or social pressures on the greater system. How can you measure and show, however abstractly, the aggregate impact of these forces? Okay, so this is a diagram. Okay, these are just conceptual ideas and directions for you to follow. So if you're getting ideas from this, good. If you're not, sit on it for a week and reread them. Superior projects should stress part-to-whole relationships. So again, systematically working across your drawings to reflect impending change on the total system. The methods of drawing and automation you use in your project will be critiqued both methodologically and conceptually. So the methods you use in balance with the concepts you're trying to show. And essentially the same, similar outputs. But since you are doing a typology or a topology, you will show them as a series of tiny A2s that are aimed at A4 representation. And for both of them, a printout of the working methods that you use to make it. So a print of your Python script, if you scripted it by writing, directly from the writer window, so all of the colors come out with it, the for loops turn out blue, etc. So directly from the Python window, or if you are using Grasshopper, an equivalent print of that.
You just copy and paste, or is there a way to?
I don't know about Grasshopper. I haven't tried. So.
But for Python?
Oh, Python definitely. Python you just print.
Oh, just
You can print directly from the window.
咁點樣整個 single topology and topography？
應該有 step by step 咁。
Okay, let's take a 5-minute break.
係咪聽日會㗎？係咪今一陣間會？唔知應該後邊有寫我覺得。嚇？
你啱啱應該冇落晒。都冇，唔係咯，唔好 share 就咁樣。
因為你頭先笑點啊？
你要開始明白。